Welcome to Everyday Counts with Jim Zarling, and today's topic is ultra high performance concrete, and our guest is Devin Harris. Devin, thank you for joining us.
Yeah, thank you for having me.
And why don't you tell me, what is ultra high performance concrete and how is it different from regular concrete?
Okay, so ultra high performance concrete, it's actually a rather interesting new type of concrete that's been out for maybe 15 years or so. And where it's different from conventional concrete, I actually have a couple of examples here. It's different in that traditional concrete has coarse aggregate, so this is basically large rocks that are embedded inside the concrete. Ultra high performance concrete uses no coarse aggregate, and the idea behind it is that it creates a really dense matrix, and that's where the strength is derived for the ultra high performance concrete.
Excellent. What are the potential applications of ultra high performance concrete?
So in the United States, ultra high performance concrete has been used in a number of infrastructure applications. Mainly it's been used in bridge applications. And so the couple places we've seen it used is an optimized shape that's been constructed in Iowa. We've also used it for overlays and thin bonded toppings. And where it's gaining a lot of traction is joint fill applications for pre-stressed, precast girder sections. And the idea behind that is that you're taking two pre-stressed members and actually filling in the joint and connecting the two in an actual structure.
Okay. How could ultra high performance concrete be used to help our local construction process?
So one of the issues with all infrastructure as a whole is that we have a lot of failures, and failures tend to occur in joints. And so when you have the potential for contaminants to get down into the joints and get down in the support systems, that's where often the deterioration starts to occur. And so this material is virtually impenetrable. It doesn't allow leakage of contaminants, and so it can be used in a lot of different applications. I think at this point it's really up to the end users to figure out where the optimal application will be for their particular case, but the key is durability. I think that's the fundamental thing with this material.
Okay, and what are the limitations of the ultra high performance concrete?
I would say that the fundamental limitation to date is probably the overall cost of the material relative to our existing materials that we use now. So ultra high performance relative to concrete is probably on the order of magnitude higher in costs. And so what you end up doing when you use it is that you can't use it in the traditional sense. You tend to use it in thin, smaller sections where it's optimally used.
Okay. What are some of the distinguishing characteristics between regular concrete and ultra high performance concrete?
Okay, well that's actually one of the neat things about ultra high performance concrete is that its strength characteristics are an order of magnitude larger than conventional concrete. So if we were to take our conventional concrete here, we might estimate that the strength, compressive strength, is on the order of maybe 4,000, 5,000, 6,000 psi. Ultra high performance concrete can achieve strengths of 30,000 psi. So it's significantly stronger than our traditional concretes. While the strength is important, the other thing that's probably the most beneficial aspect of the UHPC is that it has exceptional durability characteristics. So it's very resistant to freeze thaw, it's very resistant to chemical attack, and it also typically uses fibers internal. So if you do get cracking, which is inherent to concrete, they're usually small and tightly distributed cracks. So when we get contaminants, they don't make their way down through the concrete.
Okay, another question. Say I'm redoing my front yard, my sidewalk. I do that. These kids always want to write their names in the concrete. All right, can they write their name in this high performance concrete while it's still wet? They can.
They could. It depends on the time. So ultra high performance concrete, unlike conventional concrete, is usually considered like a self-consolidating concrete. And so when you actually cast it, it flows into place. Depending on the workability of the traditional concrete, it usually will be stiff for a period and then it'll harden. Ultra high performance concrete has some flowability, so if you tend to write your name at that stage where it's still
I don't
workable,
it's the kids in the neighborhood.
If the kids decide to work, if they do it after a certain period of time, it'll stay. If they do it too early, it will fill in the gaps.
All right. Well, that's our time. I'd like to thank Devin Harris for stopping by and talking with us about ultra high performance concrete. Keep an eye out for more videos from Everyday Counts with Jim Zarling.